that is 1 and 2, and we are supposed to be live. Alright, so back another day, trying to learn SIG. I actually had a video. Hopefully nothing crazy pops out on my watch later playlist. Watch later, yes. I could have sworn I had it in here. Sick. Is there no sick? Quit here, no. Okay, well. Something like sick learning resources or something like that. Get good at sick with these resources. This is the one that I had. Okay.
Roman General 23 asked me this: how did I get good at Zig?
Yeah, let's see. Maybe I don't want to like just steal the whole guy's content. Well, maybe not steal, but you know. Right. So let me just grab the link in here. Share. Boom. Okay. I actually do not want the music to stop, if that's possible. Yo. There we go. Announcement. Boom. This. Boom. Actually, live for not that much. Boom. Boom. There we go. We do this shit. Alright. And then I can go back with the music. There we go. Okay, so introduction to SIG. Buy the book on Amazon. Okay, if you like this project, does that mean that I have to 100% do that? Or can I maybe read this and then do that? The present introduction to the SIG programming language. Revelate about this book. Repository of the book. Good. Alright, so what else can I do? Shit. Now that I had it loaded. Okay, 999 on Kindle is not that bad. I might think about it. In your web browser. Alright. So this is the actual book itself, I imagine. Alright, good. After you're not in a command from this compiler, some new files. Okay, yeah, this is all pretty much just done here. The file, let's see. Okay. It has a valid build.sig.sound info, which describes the project. You can easily include the library in your project by simply listing the external library in your build.sig.sound. Which you can describe your project and also declare a set of dependencies of your project that you want to fetch from the internet. In other words, you can use this big build.sig.sound file to include a list of external libraries in your project. Alright. Alrighty. So what else can I do? Actually, let me save this in the SIG. Nah, I'll just put it in here. The file root.sig. Let's take a look into the root.sig file. You might have noticed a line of code with an expression as well as an icon. Yep. Also notice the add import call at the first language. This is built-in function to import functionality from other SIG modules in our current module. This import function works similar to the include C++ or to the imported saving in Python or JavaScript code. Good. In the root.sig file, we can also see how assignments creating new objects are made in SIG. Huh? You can create a new object in SIG by just using the syntax const bar name equals value. Okay. Okay, so you're really going through the basics in here. Alright, so maybe I should jump into this one. SIG syntax in the last chapter. Okay, maybe I should know something else about it. Export function. Okay, so this is that it's going to be used as the but what does the export keyword mean? In this case, export, I mean, I guess it's going to be exported. Is it like TypeScript in JavaScript? Or you can use it across other files? I imagine so, but actually, SIG, try SIG. Let's see if I can do, I don't care. Can I just declare a function? Function, whatever. Okay, yeah, I do have to split. And this should just work, build, run, whoops. Oh, I still don't know how to type. Okay, great. Okay, it does work. So what is the difference between whatever? It works. Alright. So I'm not too sure what is the difference between this and this. Does the same thing. Maybe functions are public by default. Don't know. Alright. What would export mean? I mean, I would have to include a whole other file in the fucking build.sig, which I might not be ready for that yet. Using the fn keyword, we're declaring a function called add. Okay, in the root.sig, which has two arguments, a and b. The function returns an integer of the type either to as result. Domain.sig, yikes. Okay, main indicates that this function can either return nothing or return an error. The exclamation mark in the return type annotation is an interesting and powerful feature of SIG. In summary, if you write a function on something inside of the body, of this function might return an error, then you're forced to either add the exclamation mark to the return type of the function and make it clear that this function might return an error, explicitly handle this error inside the function. Alright, well, let's try that one out. Let's just do error try. I'm just gonna say boy, and then return error. Can I just do this? Okay. Yo, whoops, run account. Gotcha, man. Alright, so maybe this is gonna say something like whatever error, and then error try. I could say try error try. Say build run. Try error try. The following command exit with error 1. Okay, is it because I just return or whatever? But actually, we have a bit of fun in here. So I could say flag, which is going to be you wait, and so I can say if you wait. Actually, let me say so if flag is bigger than 0. Can I actually use this as in, okay, so I can use this and then I can say, although it would be Then this is going to be I8 because you're just going to return value. Sorry, flag. Else you're going to return error dot negative number. Sorry about that. Okay. Now I do this. I actually don't call the function, which is great. Try or try. I should probably wait. Why did this fail then? Expected 1 argument. There we go. Yo, Aspel, I don't know if you're still in here or if you are changing your account, but how are you doing, man? Fuck. How's the emulator going so far? So this should be true. Alright, why did you ignore? It's doing pretty good. Okay, so you actually changed the account. God, Right. I mean, what am I crazy? Am I crazy? Strengthener library documentation. I just want types. That's all I really want. I just want types. What are my types? Language for reference. Types. Primitive types. There we go. Signed 8-bit integer. So why do you decide to do this? Interesting. All non-void values must be used. Value of type I8 ignored. To discard the value, assign it to. Okay, do I have to do? Don't tell me this is what I have to do. It is. What the fuck? Since yesterday I've literally been disassembling the Tetris initialization sequence by hand because my emulator is doing some weird stuff it shouldn't be. Damn. How's it going? Sig is going pretty good. I mean, I do kind of like it. It's kind of fun. I've been seeing videos today and some sort of guides, and there's some crazy stuff that you can do with this, but I'm excited to keep learning. I mean, right now I'm just trying to grab the basics of what this language can do, and then maybe, for example, there's a project one here, and then I can do a service from scratch. I literally just found this today, but it looks great. So yeah, I'm probably gonna read this book, and then maybe I'll try to do. Maybe I can try. I don't know how I failed after this. Do any graphics API support SIG? I think it does. I mean, if you mean by graphics API OpenGL, I'm not so sure. I'd say it can because you can use C libraries on SIG. But for example, you can for sure use Raylib, and I don't know if you can use SDL, but Raylib for sure, which is the one that you're using. So handy as hell. Okay. The main function, yeah. This may also if you come from a high-level language, because in high-level languages such as Python, if an error occurs somewhere, this error is automatically returned and the execution of your program will automatically stop. Even if you don't want to stop the execution, you're obligated to face the error. Okay. Raylib is goated. Raylib is goated. I actually didn't know this, but the guy that created Raylib is Spanish. Like, what? I didn't know that until I saw an interview from him on DJ Debris' channel, and I was like, this guy sounds very Spanish. He has a very strong Spanish accent. And then I looked him up and he was Spanish. Okay, just cool fact that you should know. Okay, compiling, sure, build exe. Hello world, compile and execute at the same time. Sig run. Windows users, I cannot really care about you. For example, the Windows you would like to get the error message exposed below. Alright. To instantiate the stdio object, okay. I don't care. Compile the entire project. It's going to be a SIG build. I did not want to go there. How to learn SIG? First, you can join a community with SIG programmers to get some help when you need it. I'm sure I might actually join this. Join. Boom. SIG community, Discord, select Telegram. Why did I just see a Pedro Pascal thing? Alright. Is to simply read SIG code. Try to read SIG code often and things will become more clear. A C++ programmer will also give you this same tip. It actually does kind of work. From other SIG code bases such as JavaScript runtime, Bun is actually done in SIG. That's crazy. 60% on SIG. I actually had no idea about this. Good for them. Good for them. Right. Creating new objects. Using the keyword bar in SIG is similar to using let must in Rust. Alright. It's not valid. Of course it's not. You need to transform your immutable or constant object into a mutable. You can do that by using the bar keyword. Okay, yeah, I mean, it makes a lot of sense. Thank you. However, if you took look at the example below, you will notice that we have not only declared the age of object with the bar keyword. What if, sorry, but we have also explicitly annotated the data type of the edge object with UATF this time. Okay, so you can declare the type right away. Just remember to always annotate the type of the object explicitly in your code. Actually, another weird thing that I found is if you try to declare a pointer, I don't know how you would do it, but I normally would do int, you know, and then I would say pointer, for example, right? And then I would assign whatever value I would like to give it, or I would just give it no, right? But turns out in here you cannot do that. The way to do it would be const pointer pointer i16, and then you can just give it as no. That's a pretty crazy way. Like, why can I just not do this, you know? Whoops. I cannot do this in here. And then, for example, let's say you already have your pointer, and then I say, hey, bar pointer. And then I could say, hey, what if I want to take the actual value? These similar projects have been crazy learning, especially for C++. I mean, it's probably the best way to learn a language. Just get your hands dirty on a project. But yeah, if you want to take the value of the pointer, you would say, well, let's just say I want to call this function. I want to say pointer, and to take the value, you would say, okay, pointer. Actually, would this actually work? No, I don't think it would. Pointer, I don't think I could say null at first and then test bar. But I don't think this is actually going to work. Yeah. Expected type i16. Okay. So I cannot leave it as null. And now why did you fail? It's not able to get the value. And turns out the way to actually get the value is to type this. Well, I mean, I already had it in here. But yeah, sorry. This is how to take the value, which honestly, it's a bit of a pain in the ass having to do the dot and then the star operator, but fuck it. Let me have this as I had it before. Great. Alright, introducing SIG. Is this not what I already had before? Creating new objects. There's no such thing as any use objects. I'm starting to like using C++ a lot. I mean, it's actually a great language. It's very powerful, and having the class abstractions is great, but also having the control of C is great as well. And then some of the features that it has, like the built-in strings, is great, and some other things, of course. Anyways, must be used in some way. You can call a method that belongs to this particular object. Okay, it doesn't matter which way you use it, as long as you use it if you try to pick this row. If you try to declare the object but not use it, the SIG compiler will not compile your SIG source code. Warning that you have unused objects in your code. Alright. Every time you declare a new object in SIG, you have two choices. You either use the value of this object, or you explicitly discard the value of the object. Alright. Okay, the compiler did not complain about any use constant to explicitly discard the value of any object. All you need to do is assign this to a special character in SIG, which is the underscore. Will automatically discard the value of this particular object. Huh? Wait. What the fuck does this mean? So can I do something like, let's just do the same exact call age 15. And then what happens in here? Can I do print value with age? Oops. Pointless discarded local constant. So it's like getting rid of the variable. Using a discarded value. This shouldn't work at all. If I do this, and then pointless discard, yes, and then it's going to say the same thing. Yeah. Okay, good. You must mutate every variable object. Okay, primitive data types, arrays. Arrays are pretty weird to declare. Okay. The object alias, I'm not explicitly specifying the size of the array inside of the brackets. Instead of using a literal value like the value 4 that I use in the NS object, I am using the special character underscored. This syntax tells the SIG compiler to fill this field with the number of elements listed inside of the curly braces. It's for lazy or smart programmers who leave the job of counting how many elements there are for the compiler. Great. Great. Anyways, in contrast, you can also select specific slices or sections of your array. Okay. So would it just pick 1 through 3? The elements at index 1 and 2 in the NS array. Yo, sup, man? Yo, what's going on, Joycey? How you doing, man? How you doing? All right. All right, sorry about that. I'm back. Okay, so what the actual fuck? More precisely, the elements at index 1 and 2 in the NS array. So what does this mean? What SIG? It's a programming language similar to C with some modern features. I guess that's what you could say about SIG. Not so sure about this one right here. The Intel, oh, it's not inclusive. Okay, that's what I thought. Goes from the first to the last element of the array by using serial or length. Okay, kind of pointless, but alright. More on slices. I don't really want to know much about slices at this point. the array concatenation operator, and the array multiplication operator. Alright, is they work only when both operands have a size or a length that is compile time known. Okay. So I guess if I do have a dynamic array, then it's not going to work, or if it's empty or whatever, I don't know. Oh, actually I don't want to try this. Let's see what this actually prints. std out. Of course it was going to fail. Root source file struct std has no memory name print. That is true. But try std out. Do I have to import that? Const std out. Import. Whoops. Std out. That's what I thought. No module name std out. Maybe this uses a older version of SIG. I heard about Rust not SIG though. Is it a new one? I think it's pretty new, yeah. SIG, I don't know when it actually got launched. But yeah, I think somewhere in like the 2010s, 2015 maybe, something like that. Deblock. Yeah, I couldn't tell you when this was released. But yeah, it's pretty recent. It's not even in a 1.0 version. I think it's only like 0.15, 16, is it? SIG version. Alright, SIG version 0.16. Debug.print. Why do you keep failing? Found void. Expected error unit type found void. Found the actual fuck. Why would this not work? I mean, that's pretty crazy. Do I have to pass an identifier for this? Print arrays in SIG. Okay. Length any. C point length. What is the any here mean? Is it memory safe? I don't know what that means, but everybody like asks for it. I don't think it's, well, I mean, I couldn't tell you right now. I mean, I guess it sort of allows for the same kind of like memory manipulation things that you can do in C. So technically it's not fully memory safe, but it does give you a lot of tools and sort of ways to manage and handle the memory in a much safer way than C. So it's like not fully memory safe. Okay, so why am I not able to? What the try consider mid and try. Could that be it? Probably because it was expected only, I mean, because the try was expecting an error. It still fails. Great. Being debug has no memory name flush. SIG flush output. std out printf. What the actual fuck is going on? Is std out an actual thing? Std out dot flush. Nope. Okay, so maybe this actually got introduced in a new change or something like that. Don't forget to flush. std.io get std writer print. God damn. So now it should work. It's not working. There's no longer name IO. Okay, well I'm just gonna fucking tell you to suck it. Okay, it prints the entire thing. So what would be the difference between this, say any, you cannot form an array without, okay, so I need to specify it for the array. Or I could say, this should work. There we go. Okay. So I do need the any. But I guess I can do this. Yeah. Okay. Any is a format specifier for an array. Boom. Okay. Good to know. I should probably delete one of these. Runtime versus compile time known length in slices. Okay. Because we know both the start and the end of the range, and then we can do the slice. If the range of indexes is not known in compile time, then the slice object that gets created is not a pointer anymore. And thus it does not support pointer operations. For example, maybe the start index is known at compile time, but the end index is not. The range of this slice becomes runtime known only. And what the hell does that mean, bruh? I mean, in other words, the end index of the range is the size of the array file contents. Because we don't know how many bytes are stored inside the sub list, because this is a file, someone might edit this file tomorrow and add more lines or remove lines from it. Now, if the file size can vary from one run to another, then we can conclude that the value of the expressing file contents line can also vary from one run to another. Yes, as a consequence, the value of expressing file contents len is runtime only. As a consequence of that, range 0 file contents len is also runtime only. Alright. Blocks and scopes. In other words, blocks is the limits and scope in your code. Belongs to the same scope and therefore are accessible from within the scope. These objects are not accessible outside of the scope, so you could also say that blocks are used to limit the scope of the objects. At one. So can I do, I mean, one thing I can just, I don't know, come in here and do this, right? So I can. Conspar, probably not a great thing. Try U60. What? Oh yeah, because try is a keyword. Try block. Can I just not leave it like this? Okay, without initializing it, then the undefined keyword is a way to do it in SIG. Okay. So I just cannot keep it like this. Alright. But then if I came here, I couldn't access this. Right? Yeah. Alright, so I can create those blocks. Okay. We're going to build and discuss is a basic supporting core decoder, but in order to further us to build such a thing on how strings work. But they come with extra caveats which adds more safety and efficiency to them. You can also say that SIG simply uses a more modern and safe approach to manage and use strings. Great, so this is a C example of how strings work. And then I guess this would be the, so you can declare an array of 1024 bytes. Because the length of the string is always present and accessible in the string value itself. Okay. Try steady out print. Alright, another point is that SIG always assumes that the sequence of bytes in your string is UTF-8 encoded. This might not be true for every sequence of bytes you're working with, but it's not really SIG's job to fix the encoding of your strings. Today, most of the text in our modern world, especially on the web, should be UTF-8 encoded. Alright, so you will have problems in SIG. Let's take for example the word hello in UTF-8. The sequence of characters hello is represented by the sequence of decimal numbers 72, 101, 108, 108, 110. So if I take this sequence of hexadecimal values and ask SIG to print this sequence of bytes as sequence of characters, so you take this as bytes and then print as, I guess, string here. STD out floss, which does not exist anymore. Okay. Slice, iterating through the string. So if I have my string object and then okay, for string object byte, then I could just do that. Actually, let me try that one out. So I can just say alright, so this would be a way of doing things. Although I could technically say this as well, right? QA, then we wouldn't have a problem, and then for string object, I guess debug that. God damn. I'm gonna actually print just one X. Okay. Yeah, but this would probably print in hexadecimal, no? Right. Oh wow. Found const. Okay, so it turns out I can not quite do that. What if I do want to print the character itself? Okay. So, X to print. Alright. Better look at the object type of. So I can get a type of thing. Great. Byte versus Unicode points. God dang. Some useful functions for strings. Compare if two strings are equal. Split scholar. Okay. Starts with to check if strings are with substring and string concat. Good. So I could probably do stuff like const string goes at port. This is std, right? std dot. Then I could say string dot, and I don't know. Which should crash because it's not doing anything. No, wouldn't std dot mem available with module root. I thought you could actually do that. Oh, okay. So you can do this. Dot mem. Okay. It's going to say expected 3 arguments, found 0. Anyways, I don't need to give this so much thought. 15.6. If we take Rust as an example, Rust is for the most part a memory-safe language by enforcing specific rules to the developer. Holy shit, my boss is graspy. A memory-safe language by enforcing, yeah. In other words, the key feature of Rust, the borrowed checker, forces you to follow specific logic when you're writing your Rust code. And the Rust compiler will always complain every time you try to go out of this pattern. In contrast, the SIG language is not a memory-safe language by default. There you have your answer, Josie. There are some memory safety features that you get for free in SIG, especially in erasing pointer objects. But there are other tools offered by the language that are not used by default. In other words, the SIG compiler does not obligate to use such tools. The tools listed below are related to memory safety. They help you to achieve memory safety in your SIG code. I already know what it is. Helps you guarantee that your program feeds the allocated memory even if a runtime error occurs. That is really good. Out. Okay. Pointers and objects are not nullable by default. Okay, so you can now declare a pointer to null. Great as well, but you can now leave a pointer. I mean, you can leave it undefined, which only makes things worse, I guess. I mean, I can do this. Undefined. Okay, nothing happens. Some stuff. Wait, actually, this makes no sense. Test bar pointers actually no. And I don't get any sort of problem. So what's happening here? I mean, this is not a got a fucking problem here. It's never mutated. Okay, yeah, well, I guess this makes sense. Because you can now leave it mutated, so it's like, okay, sure thing. This helps you to avoid memory problems that might arise from dereferencing null pointers. SIG offers some native types of allocators called testing allocators that can detect memory leaks and double freeze. These types of allocators are widely used on unit tests, so they transform your unit test into a weapon that you can use to detect memory problems in your code. Arrays slices in SIG have their lengths embedded in the object itself, and makes the SIG compiler very effective on detecting an out of range type of errors and avoiding buffer overflows. Good. The language also has some rules that help you to achieve another type of safety, which is more related to program logic safety. These rules are pointers and objects are not nullable by default. Okay, you actually already mentioned that, but alright. Switch statements must exhaust all possible options. Okay. The SIG compiler forces you to handle every possible error in your program. True as well. Okay, 1.0. Alright. Alright, so I think I'm gonna leave it for today, guys. Not gonna lie, my voice is rusty, raspy, I don't even know how to say it, but it's kind of fucked up. But yeah, sorry for the short stream. I just spent the entire day doing one thing for college and it was fucking tedious as hell. Because I had to follow a tutorial, but the tutorial was super outdated, so I just couldn't follow the tutorial, so then I didn't know how to do it because I couldn't follow the tutorial, so then I had to sort of find my way through it. It was a pretty big pain in the ass, but yeah. Thank you for being here. I'll be back tomorrow.